Okay, so today we're looking at the language of algebra, words and symbols, mostly focusing on the symbols today. Some of the symbols we're going to be looking at are absolute value, and we'll look at in a second, square root symbols, and cube root symbols. We'll also be looking at the different ways they can talk about writing addition, subtraction, multiplication, which we can use parentheses or dots, and division, which means we could use a division symbol or a fraction bar. And then we're going to look at how powers and roots, exponents and rooting, are related to one another. First thing we're talking about is absolute value. The absolute value symbol is just like two lines, and when you see those two lines, you're basically asking the question, how far is the number from 0? We always think about that distance as a positive number. So for example, if we're looking at the absolute value of -5, which is right here, we would say that it's 5 units from 0. And let's just take that out for a second. Oop, not the whole thing. And if we were talking about the absolute value of, whoops, sorry dudes, the absolute value of 4, for example, just because it's going in the positive direction, we're still going to talk about its positive distance from 0, so the absolute value of 4 is 4. Okay. Next thing we're going to talk about powers, and powers are talking about multiplying the same number over and over and over again, and that number is called the base. The little number, which is the exponent, tells you how many times to do it, and this whole thing together, the 5 squared, is called the power. So 5 squared means 5 times 5 for a total of 25. If you had a 3 there, let's say the base was 2, and you had a 3 there, figure out what that would mean. It's going to mean the base is multiplied by itself 3 times. 2 times 2 is 4 times 2 is 8. So a power is the whole thing. The base is what you're multiplying by itself, and the exponent is how many times you're multiplying by itself. Roots are the opposite of powers. So here we have a grid which has 9 square units in it, and the root here is asking for what number multiplies by itself, in this case 2 times, and then there'd be a little 2 right here to equal 9. So what number times what number equals 9, and that number of course is 3. So the square root of 9 is 3. This is so common to ask for the square root. Sometimes we don't even write that little 2 right here. Okay? If we were looking at, whoops, we're looking at now we have 36 units inside, and the square root of 36 would be, that's right, that would be 6. So it's the opposite of squaring. This is 6 squared inside, and 6 as the side length on the outside. So square roots are really common, but we also have cube roots or fourth roots. Cube roots ask you what number multiplied by itself 3 times equals x. And so you'd see a little 3 here. And in this case, we have a picture of 27 cubes. And if we were asking for the cube root of 27, we're looking at what number multiplies by itself 3 times. And you can see that number right there in the edge of the cube, because a cube, to find the volume, requires you to multiply 3 times 3 times 3. 3 times 3 times 3. So the cube root of 27 is 3. Down here, we have a list of the first 11 perfect cubes, a number that when you take the cube root, you get a nice clean number. Most roots are messy numbers, and we'll talk more about that later. Okay, so we're going to do a little work with the symbols of addition, subtraction, multiplication, and division. We'll deal with the words in class and add that to this in a couple days. Addition really only has one symbol, and that is, the plus symbol. I'm having a little trouble. Subtraction only has a one symbol, which is the subtraction sign, which has more than one meaning. We'll talk about that later. It also means opposite and negative. So that symbol has this symbol has lots of other meanings as well, but it does mean to subtract or take away. Multiplication and division are such big deals that I'm going to go ahead and have it on its own slide. So multiplication and division, when you were younger, multiplication was always written as some number with an x and the other number. So it's 5 7 times or 5 times 7. We don't use that in algebra very often anymore because the x stands for a variable. As a matter of fact, I'm going to use a variable 5 times x. We can write that 5 times x with a dot. When it's a variable, we can just smash it next to each other, and that means 5 multiplied by x. We can write it with 1 parentheses, or we can write it with 2 parentheses. All of those mean multiplication. If we want to just do a 5 times a negative 7, we have to include that dot, because otherwise it just looks like 5, negative 7, 50, negative 7, but kind of confusing. So this particular one, for example, would be negative 35, because 5 times negative 7. Division, we do still use the symbol that you learned when you were younger, but we use a lot more the fraction version of it. So you might see 15 divided by the way, I'm going to put that in parentheses right here, this negative 3. The only reason it's in parentheses is to tell you it's negative and it doesn't get all bunched up with the division symbol. Sometimes parentheses are just there to say, hello, I'm a negative number. You can also write this as 15 divided by negative 3. And of course, that's going to equal negative 5. So when you see an equation with a fraction and like that, you don't have to get freaked out that it's a fraction. You can just think about the following. You're like, okay, what number divided by 3 is going to equal negative 2? And that number, what number divided by 3, that number has to be negative 6. And if you don't know, you can go ahead and use what we're about to talk about, which are opposite operations, to help you find the others. So this is a division problem. We can find that with an addition problem. I just said addition. This is a division problem. You can find the missing thing with a multiplication problem. You've been dealing with addition and subtraction for a long time and division and multiplication for a long time. Those are called opposite operations. Addition and subtraction undo one another. They're inverses. So if we're adding 5, to get rid of that, we can take away 5. If we multiply by 5, we can get rid of that by dividing by 5. So these are opposite operations. Addition, subtraction are, division and multiplication are, and then the fairly new things are powers and roots. Taking a number like 5 to the second power, which gives you 25, the opposite of that would be taking the square root of 25, which is 5. So it's the opposite. Notice I didn't write the little 2 there because I didn't need to. It's such a common question that we don't even put the 2 there. So we're going to put it all together and do a couple of the symbols together. I'm going to put some time in between when I ask the question and when I write the answer, so you can have a chance to kind of think it through yourself as well. So first thing we're going to talk about is an absolute value problem, the absolute value of negative 10. And I'm going to go ahead and put that over, so remember this means division, over another number. So that means we're going to be dividing the absolute value of negative 10 by 5. So first we have to think about, this is like a parentheses, we have to do this part first. What's the absolute value of negative 10? That's going to be positive 10. And then we're going to divide that by 5. So we end up with 2. Okay? So once again, you've got to do the funky symbol guy first, because it's like a parentheses, and then you look at the operation. So here we have, how about this? We're smashing something together. So this means what operation? Right here, it's like there's a missing multiplication symbol there. It's 3 times the square root of 49. We have to do the square root of 49 first. So it's 3 times square root of 49 is 7. And then it'd be 3 times 7 is 21. Last thing, I'm going to go ahead and erase all this real fast. I'd like you to go ahead and think about this one. A negative 16 times, well, no, I'm going to write it this way with the parentheses, times 2 divided by 4. So you're going to go ahead and do the top part first. Negative 16 times 2 is negative 32. And then this is division. Negative 32 divided by 4 is negative 8. There is a little quiz for you at the end. It's not graded. They never will be. It just gives me gives you feedback right away, and also gives me a chance to know what I need to work on with you when I see you. Hope all is well.